Welcome to this video. Today we will have a quick recap on periodic classification of elements for class 10. Materials, periodic classifications of elements. Now we know all the matter around us, all the materials around us can be classified as matter if they occupy space and if they have a mass. Such materials are also classified as elements, compounds and mixtures. Elements are the smallest type of substance that have characteristics which are different from others, while atom is a small indivisible particle of an element which has all the characteristic of an element. Molecule is the smallest indivisible part of a compound which has all the characteristics of compound. The molecule can be further divided by chemical means into constituent elements. The characteristics of molecules and the characteristics of elements are different. Carbon, nitrogen, etc. are the elements. There are about 100 odd elements now. Some of them are natural, many of them, around 80-90 of them are natural, while the rest of them are discovered or introduced or invented by man in the lab. Now, to learn about these elements and compounds, first we need to understand what are all the different elements and what their characteristics are. So people try to tabulate these elements. So we were trying to create a periodic table. Many attempts were made in classifying, in putting it into different buckets. Dobrainer's triads, Newland's law of octaves, Mendeleevs periodic table are the most important methods of classification of periodic table. Later, the modern periodic table has been developed and it has been adopted, and now it is a stable one. The periodic table is drawn based on the grades of the properties of the groups of the elements. Based on, then we will have a look at valency and atomic number also by the end of this video. What is a periodic table? Periodic table is a table of the elements. Why it is necessary? The elements needs to be arranged in rows and columns so that it will be easy to study about each of them. Because we cannot separately study, we can study groups of elements when we have the rows and columns. A particular row will have a specific characteristic. A particular column may have a different property. So it will become easy to study. Because knowing the properties or the uses of various elements, which are hundreds in number, is little difficult, and if we have a periodic table we can safely assume the similarity in the property of the elements based on in which group they fall, based on which row or which column they are. This was the intention of creation of a periodic table. Now the elements are classified into groups on basis of similarity of the properties. First is Dobrainer's triads. Dobriner said when elements are arranged in group of 3 in the increasing order of atomic mass, he looked at the atomic mass. Increasing order of the atomic mass, the middle element of the group has the atomic mass of the properties roughly equal to or average of the other two numbers. So lithium 7, sodium 23, K39, when you arrange 7 plus 39 by 2 is approximately 23. So the properties of sodium are roughly average of the properties of lithium and potassium. That is what he tried to say. But this applies only to certain elements. When elements are arranged in a group of 3 in increasing order of the atomic mass, the middle element of the group has the atomic mass and properties roughly average of the other two elements. This is the rule of Dobrainer's triad. Then we have the Newland's octave. Newland's octave. Octave means 8. So just like we have Sari Gama Padani 7, octave is 8, a musical chord. So it is arranged in the order of increasing atomic mass. Dobriner also arranged in the order of increasing atomic mass. Properties of the 8th are repetition of the properties of the first. He said properties of the 8th are repetition of the properties of the first. Instead of 3 and then taking an average, he said arrange in group of 8, the 8th element will be the repetition of the properties of the first. So here also this works well for lithium, sodium and potassium. It works well. But it works only for lighter elements. It could not apply to all the elements. Newland's law. Then came Mendeleev with his proposition. What did he say? The properties of the elements are periodic function of the atomic mass. That was what? Here also it was there. It was an increasing atomic mass. This is how they arrange. He also said it is an periodic function of atomic mass. But elements should be placed in increasing order of the atomic mass. That also he said. But he said not just place them, you place them in groups. 8 vertical column and 6 horizontal rows. The columns are called groups. The rows are called periods. So he created vertical column and horizontal row, groups and periods. At the time of proposition of this periodic table, there were 63 known elements and all the elements could be covered here. He also reserved some space for the undiscovered elements. For example, there were elements for which we had word eka. Eka is a word which means one in Sanskrit. So word eka was added and then they left the space there for that what do you call element to be later discovered and placed. So that is why we have a germanium type of elements now. Eka boron, eka aluminium, etc. were there. So we know boron, but there was a place and people believed that there will be an element which is similar to boron which will be discovered later. So that is a specialty of this periodic table. 8 vertical columns, 6 horizontal rows. It was known that more elements will be there which will be fit. So this was okay. But there was some problem. The problem is cobalt with a higher atomic mass was placed before nickel. Tellurium with a higher atomic mass was placed before iodine, etc. Also, it did not provide for the noble gases. Noble gases were not known at that time, but boron, neon, argon, etc. it did not provide for, though we consider them as elements today and it has to find a place in the table of elements. There was no separate place for isotopes. That was another problem. There was no separate place for isotopes. We learnt about carbon 60 in some other video. The position for hydrogen was disputed. Hydrogen position could not be agreed upon. That was a problem with the Mendeleevs table. Then came Henry Moseley. Henry Moseley in 1913 predicted something. What he said, atomic number of an element is a fundamental property, not the atomic mass. Not the atomic mass. He said atomic number is a fundamental property. Atomic number is the fundamental property than the atomic mass. Earlier, all the listings was based on atomic mass. So, if elements are arranged in the increasing order of the atomic number, that was his requirement. Then the properties of the elements repeated after certain regular intervals. Properties of the element repeated after certain intervals. He also spoke about the rows and columns based on the properties. But then he said this repetition of the properties of the numbers is called periodicity of properties. This concept was brought in by Moseley. What he said, this periodicity of properties depends upon the electronic configuration. What electronic configuration? Outer electronic configuration, that is K, L, M, N, O. We have the shells or the orbits in which the electrons revolve around the nucleus. Now the outermost shell is the shell on which the valence electrons are there. The outer electronic configuration will decide the periodicity in the properties. Then he arranged 18 vertical columns or groups. In place of 8 columns, he arranged 18. And in place of 6 rows, he had 7 rows. He brought in 6 rows and in the place of 6, 7 and in the place of 8, 18 vertical columns or groups and periods. So he brought in groups and periods. Earlier also there were groups and periods, but now he made it more comprehensive. The number of elements in any period is fixed by the number of electrons. Number of elements is fixed by number of electrons. Number of elements in any period was fixed by the number of electrons that can be accommodated in that particular shell K, L, M, N, O. So how much can be accommodated? It used to be in the 2 into n power 2. What is that? In first it is 2 into where n is 1, 2 electrons only in K shell. In L we have 8 electrons. In M how many will be there? 2 into 3 power 2. 3 power 2 is what? 3 is the n. So like that this will keep on increasing. K, L, M, N, O, P. Maximum number of shells is known to us today Q. In L we have a octet. Octet is 8. So K first we have only electrons which are having atomic number as 1 or 2 because maximum is 2 electron possible in K shell. In L shell maximum 8 electrons are possible. So what we have? We have elements that have 3 or 4 or 5 or 6 or 7 or 8 as the atomic number. We have 9 and 10 also. Why? In 9 and 10, 8 can be accommodated, 2 can be accommodated in K and 7 in L. Likewise, 2 is accommodated in K and 8 in L. So it is full. Now you cannot have 11 because 2 plus 8 plus 1 it will become. So it has to come here. 11 has to come in the third shell M. So number of elements in any period is determined by. So this is period 1, this is period 2, like that we have K, L, M, N, O, P, Q. KLMNOP, Q. That is why we have 7 horizontal rows. In each row, it will tell us how many electrons are there in that. This has only 2 electrons maximum. This has maximum 8 electrons. This has maximum 8 electron in the third shell. So, if there is an element in N period, that means there will be 18 or more electrons. 18 or more electrons. This is the way Henry Moseley's discoveries or Henry Moseley's propositions devised the new periodic table in 1913. And this has been invoked till today because it had stood the test of time. Now, there was special series of 14 elements each. For that, he had a separate row. Then one element of atomic mass number 58, of this there are two. One is lanthanide. One is lanthanide, one is actinide. One is lanthanide, one is actinide. So special series. So lanthanide is 58 to 71 and lanthanide is 90 to 103. These are special elements which are kept separately at the bottom. And then since the outer electronic configuration changes as we go from left to right, here we have seen how many electrons are there in each of the shells maximum. So this will decide on which period, that is horizontal row is called the period, in which period it will be. But in the column also, when we move left to right, the electronic configuration changes. Electronic configuration changes when we move left to right. So because of this, there is a gradation in physical qualities. Gradation in physical qualities or gradation chemical quality properties also. Characteristics change as the electronic configuration changes. Then regular gradation on moving from top to bottom also. When you move top to bottom also, you will have a regular gradation, because why? The number of electrons, the number of shells change when you go from top to bottom. This is the number of periods. Top to bottom is period, left to right is the groups. Now, what is a periodic table that we have been talking about? This is the periodic table. So, it accounted for hydrogen. What is special about hydrogen? The one number on the top is atomic number, the name is hydrogen, H is the symbol. And the number of electrons on the shell is 1. Atomic weight is 1 and this H is a symbol. Now, this is helium. Helium has 2 electrons. Likewise, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So, lithium, beryllium, boron, carbon, nitrogen, oxygen, what is special about this row? In this row, the number of electrons keeps growing. As we grow down, the number of shells keep growing. Lithium, sodium, calcium. This is what we saw in the Mendeleevs table and Dibrenner's table. They were talking about lithium, sodium, calcium. So, this is coming from here. Lithium, sodium, calcium. And then we had 2 extra rows of 14 elements, which are called actinide and lanthanide series. Actinide and lanthanide series, especially extra. So, this accounts for most of the elements. The specialty is we can separate or identify the noble gases. We know where are the metallic properties, where are the non-metallic or metalloids. We know which are all the gases. Helium, neon, argon, xenon, all these are the noble gases. Carbon, nitrogen, oxygen, potassium, sulfur, chlorine, bromine, iodine, these have a separate qualities. Then boron, silicon, arsenic, beryllium, this S shape has a separate qualities. Germanium was discovered later, antimony was discovered later. This was not there originally when the table was being drafted by Mendeleev and others. So this is our periodic table. Coming to valency, what is valency? Combining capacity of an element based on number of valence electrons. It is based on number of valence electrons. What is a valence electron? The number of electrons required to complete the octet is the valence electron. The combining capacity of an element is called the valency, because element combine together each other by giving or taking or sharing electrons. Giving or taking or sharing electrons. When an electron is given, it occurs a positive charge. When an electron is taken, it occurs a negative charge. So when you have more electrons, you will have a negative charge. When you have less electrons than the proton, you will have a positive charge. These are cations and the anions. So cations and anions are little unstable. They will try to regain their lost electron or give away the extra electron. How they do? Either by combining and forming a compound or sharing electrons and forming a octet on their outermost shell. Now this valency is the combining capacity of an element. Electrons in the outermost shell of the atom. From left to right in a period, the number of valence electron increases from 1 to 8. So it increases from 1 to 8. When it reaches 8, again it has to come because ninth one will have to go to the next row. So it increases from 1 to 8. All the elements in the group have the same number of elements. All the elements in the group will have same number of valence electrons. What is group? Group is the 18 vertical columns. Group is 18 vertical columns. So all the elements in the group will have the same number of valence electrons. If the number of valence electrons change, it will change from this group to this group. This is a period, number of shell. This is number of valence electron. So the number of the shell is based on the period. The number of the shell, number of the electron is based on the group. Number of the electron is based on the group. Number of shells available is based on the period. Valency of an element is neither equal to the number of electrons or is equal to 8 minus the number of electrons which are available for sharing. So in sodium it has 2 plus 8 plus 1. So it will become 2 plus 8 and 1 extra. That is how it is in the shell. Likewise, magnesium is 2 plus 8. This is 2 plus 8 and it have 2 extra, or valency is 2. It has 2 electrons on the outermost shell. The number of electrons on the outermost shell which has a capacity to combine to make it an octet. Chlorine has 287. So 287 means 288. How? If you give an extra electron, it will add it to it and make the shell complete. This is how it happens. Now coming to atomic size. Atomic size is the radius of the sphere. We assume that the nucleus and the atom is a sphere. The atomic size of an element is nothing but the radius of the sphere. Atomic size of an element is the radius of the sphere. The distance between center, which is a nucleus, and the outermost shell. Distance between center and the outermost shell is the radius. The shell that contains electrons in an isolated atom. It is measured in angstrom. Angstrom means A and the small dot on the top. How we write this is angstrom. Angstrom. It is measured in picometers. Angstrom, picometers. On moving from left to right, the atomic radius decreases. On moving from left to right, the atomic radius decreases due to increase in the nuclear charge. The nuclear charge increases because number of protons increase. When the number of protons increase, they will pull the electrons closer. On moving down the group, the atomic radius increase gradually. The atomic radius increases when you are moving down also. Why it is increasing? Because new shells are being added. The distance from the center to the shell is the atomic radius. Increases the distance between outermost shell and the nucleus. So left to right, the radius decreases. Because pull the electrons closer. The number of protons will pull the electron closer. On moving the group downwards, the radius increases because number of shells is more. So if new shells are there, the distance will be more. Now what are metals and non-metals? Group 1 to 12 are metals. So we know what are the metals. Ferrous is a metal. Manganese is a metal. So these are all metals. Group 1 to 12 is metal. 1, 2, 3, 4 up to 12 it can be considered as metal. Right? They are electropositive. Group 13 to 18 are non-metals. Group 13 to 18, these are non-metals. Group 13 to 18 are non-metals. They are electronegative. And then we also have metalloids. What are metalloids? Metalloids are borderline elements or semi-metals, or which have characteristics of some metals and characteristics of non-metals. Boron, silicon, germanium. Arsenic. These are the metalloids. Non-metals tend to form bonds by gaining electron. Non-metals will gain electron because they are electronegative. They will gain electron to remove the negative charge and become positive or nullify. Metals tend to lose electron. They are electropositive. Then means what electron they have? Electrons extra. They will tend to lose the electron to form the bonds, and these are yellow color. This is the non-metals, right? After metals and non-metals, we will have also look at the characteristics of these metallic or non-metallic elements. There is a variation in the period. From left to right in the period, the metallic character increases. The metallic character increases. That is why you have a chromium which is less metallic than manganese, and ferrous is more metallic than manganese. Chromium, metallic, ferrous, cobalt, nickel, copper. So this is the metallic character. From left to right, metallic character increases, non-metallic character decreases. Non-metallic character decreases. From left to right, non-metallic character decreases. Moving down the group, metallic character increases. Moving down the group, metallic character increases. This is manganese, this is rhodium. So this is platinum, this is nickel. When you are moving down the group, metallic character increases. Down the group, metallic character increases. Left to right, metallic character decreases. This is one observation when you look at the table. This is how it is kept. This is the relationship between the various elements in the table. Metals tend to lose electron, that we have already seen. Metal tends to lose electron while forming bonds, and non-metals tend to gain electrons and form the bond. Metalloids are having common characteristics. Thanks for watching this video. We were having a quick revision of science periodic classification of elements class 10.